Thank you guys, and welcome again to our lightning talk. I think we've already been well introduced. So this is Raphael, I'm Jacob. We work as software engineers at Bakdata here in Berlin. And today we want to talk about our solution to turn massive text streams into searchable knowledge with Apache Kafka and Qdrant. And yeah, let's just dive right in. So we want to consider the use case of product reviews here today with you. So every review kind of has like a title and a body and also a bunch of metadata. And what we want to do is to make this semantically searchable with Qdrant, so that when like a user comes with a query, for example here in green, what's the battery duration for my new phone, then we can surface the relevant reviews for that answer that query. And now if you look at that, there's quite the gap between this review document on the left with multiple relevant text fields, so we want to search the title and the body, and on the right side you see that you need to have like appropriate embeddings for these texts stored in Qdrant so that you can semantically search them. And also, and that's something that we are very familiar with at bakdata in terms of stream processing, we want to also put the challenge on top that these reviews are continuously produced over time, and of course you also want to have these new reviews searchable as soon as possible. And so then the question that arises from that is, how can we bridge this gap? And we designed a Kafka pipeline for that. So first off, as a heads up, I know it was in the abstract that it was going to be about unstructured texts, but in this lightning talk format, we just don't have enough time to go into detail on all the work that it usually takes to structure the data. So then we want to just start with our pipeline. We will talk a bit about chunking long texts, generating embeddings for texts, transforming them into a format that Qdrant can work with, and finally loading them to Qdrant. Another question is kind of like, why are we doing this with a Kafka pipeline? And for us, the main reasons are that we are very flexible in our choice of a chunking strategy, and also on the embedding model that we want to work with. And also thanks to Kafka scalability, we can scale each of these pipeline steps that we see and process millions of texts in near real time. At Bakdata, we also have extensive experience with these pipelines, building them around Kafka, running them 24/7 for various customers. And so now I've talked about Kafka already a bit. So for those that are unfamiliar with it, I'll lose some words on that. It's a distributed platform for storing data streams, and it also supports you in processing them. So there's, for example, Kafka Connect, with which you can bring in data from various sources into Kafka. Then you can have consumers with which you can read data from Kafka. You can have producers that can write data back to it. And where it becomes really powerful is when you combine a consumer and a producer into a single app so that you can read the data, do some transformation, for example, calculate embeddings, and then you can write the data back to Kafka. And in this pipeline, every one of these red components is a pipeline step that contains such a consumer and a producer, and so the data is stored back in Kafka in between these steps always. And now Raphael will go into some more detail on our pipeline.
All right, thanks, Jacob. So now I would like to go through the pipeline step by step and talk a bit more about each step in the pipeline, how it works, what it does. And we're starting off with our first challenge, which is chunking of text. So I'm sure most of you are familiar with chunking, but I will briefly go through it. So in our example dataset, we have review texts that can be anywhere from 10 to a few thousand words. And embedding models have pretty strict size limitations. It's usually around 500 to a few thousand tokens, but it can vary depending on the embedding model you use. So what we do is we first tokenize our text, and then we chunk that text up into pieces so it fits into our embedding model. And in this example pipeline, we're using a overlap of 5 tokens. You can see that on the yellow here. and this is just to preserve context between chunks and don't lose any informations. So now I want to quickly show you how a Kafka application that takes those chunks and converts them looks like. So on the left here we have our product review texts, and on the right we flat map this, and we get one too many text chunks as the output. And there's a lot more to it in the Kafka application, and I will talk about that shortly. For now, we are already at our most interesting part for today, probably, which is the creation of embeddings, the creation of vectors. And I quickly want to give an overview of what the Kafka application does. So it basically takes text chunks and it outputs our beloved vectors. And now I want to quickly go into the Kafka application itself, what it does, how it works, because there's a lot to it, even though it's pretty simple on this diagram. So we are using a combined consumer and producer approach. So we read data from Kafka in chunks, in batches, and those chunks we send off to a consumer, and this consumer passes it off to an embedder. And this embedder makes an API request to some external embedding service. And I will talk about the embedding service more later, but for now, we're getting a response from this embedding service, and then we can use a Kafka producer to produce those batches of now vectors back to Kafka. As I said, there's a lot to it, and a pretty important point here is that we can scale both services independently. So if there is high demand, we can scale up either the embedding service or the Kafka application, and if there's low demand, we can save on cost and scale them down just as to meet demand. All right, so now I quickly want to talk about the embedding service we use, and our goal here was to separate the model serving from the processing in Kafka, and we have to do that by making a network call, which is something we would usually avoid doing in Kafka. So after a bit of testing, we found that Hugging Face's Text Embeddings Inference works pretty well. It's a Rust-based solution that provides a really convenient OpenAI-compatible HTTP API, and it supports many embedding models and obviously features GPU acceleration. All right, and now that we have our vector data in Kafka, we have to transform it so that we can later export it to Qdrant. And this step is pretty simple. So what I didn't show you up until now is that in each step of our Kafka pipeline, we have a lot of metadata attached to each chunk and each review. And we obviously want to pass that metadata off to Qdrant. And this is the step to include that and store it into Qdrant. The JSON schema you see on the right is actually the JSON schema of the Qdrant sync connector. As my colleague mentioned earlier, we're using Kafka Connect, which is a pretty good way to get data to and from Kafka. And what it does is we have our transformed data in Kafka, and the official Qdrant sync connector reads the data from Kafka. It then bulk inserts it into the Qdrant vector database. And there's a lot of advantages that we benefit from using Kafka Connect, like the features we love about Kafka. So for example, exactly once delivery, or really sophisticated error handling. And my colleague Jacob will shortly tell you more about funny things you can do with Kafka Connect, so I'll hand over to him.
I just need the clicker. Thank you. Okay. We're not quite at the Kafka Connect next steps yet, but we are kind of approaching the end of our talk already. We gave you a small overview into our work, and how we turn massive text streams into searchable knowledge. We're using these scalable Kafka apps for continuous text chunking and embedding. So the great thing about Kafka is really that, for example, the embedder is also a component that usually, you have a much higher latency when you process like a single record. With the batching, you can improve it, but still, if you process a batch of text to generate embeddings, that will take a whole lot longer than merely chunking it, putting it through the tokenizer. And so as a result of that, you might want to scale up the embedder more than the chunker, scale it up more horizontally. And Kafka is like a really great platform to do that with, because yeah, it splits the data up nicely for you. Yeah, Raphael also talked about the embedding service that runs on the GPU that we use. You can also scale that as you want. And yeah, then we're using Kafka Connect for loading embeddings to Qdrant, and also the scalability is also built into Kafka Connect. So also there you can have multiple workers, so to say, that can load the data to Qdrant, and then you just need to make sure that your Qdrant vector database is beefy enough and you're using the distributed mode so that it can accept all the data as well. Yeah, and then finally you can harness Qdrant's vector index for semantic search or for building an AI agentic system. I think we've heard enough about, or not enough, but we've heard a lot about that already today, so give you some ideas. So there are other experts for that, I think. Yeah, and to quickly give you a peek into our next steps that we want to do in our project, one thing is the aggregation of chunk embeddings of single text fields. So when we have a very long text, we want to aggregate the embeddings of the separate chunks of that text so that we don't have to store quite as many vectors in Qdrant and use a lot of resources with that, but still have like a reasonably good representation of this long text in Qdrant. And then another thing is that we want to be able to do deletions with this Kafka Connect sync. So right now the sync only supports upserts, but in our case, an update, a document might also be updated in the sense that a whole section is deleted from it. For example, for a review, the review body might be deleted, and then we want to, of course, reflect this by deleting the corresponding embeddings in Qdrant as well. And for that, it would be nice to have this kind of delete action in Kafka Connect. Yeah, and and then there's like a whole realm of other possibilities that, yeah, are next steps for us. Yeah, and if you found any of this interesting today, or you have any questions, we'll be around and we're very happy to talk to you. So that's it.